Good day, and you're all very welcome to this Saturday's technical session of the CNPS. I'm Ian Cowan, I'm hosting it, and we're very happy to have back a man who has talked to us a number of times before, Stephan Gift. He's talked to us a number of times on his own analysis of phenomena, experimental phenomena, and how that could be described in terms of mathematics. And normally what we're doing in mathematics is we're using transformations from one frame of reference to another. So we're dealing very much with electromagnetic phenomena and what has led to, I suppose, the special theory of relativity in particular, and the Lorentz transformations, which a number of people in the CNPS community disagree with. Now, Stephan has in the past talked about different types of transformations, and he's talked about the Solari transformations, which are interesting. But I think he's gone into quite considerable detail about that. And if you look at the past recordings, you will find a lot of interesting information there, and Stephan's arguments as to whether they are more consonant with experimental results than existing Lorentz transformations. Now, however, there is another thing which some of us have been discussing for quite some time. The Lorentz transformations, well, no, I don't want to get emotive. The word hijack was in my mind. I was going to say they were hijacked by Einsteinian relativity, but that's too emotive for a moderator. Well, they were taken over so that they were used by Einstein, and therefore they're associated with him. But there is, of course, as any of us know who have looked at the matter, the earlier derivation of those. And in fact, it probably goes back to Voigt, who used the transformations when he was looking at things like Doppler effects. And then they were used by, well, they were used in some form by people like Larmor and Poincaré and Fitzgerald when he's dealing with the contraction hypothesis, and then developed by Lorentz. And I think it was Poincaré who suggested that they be given the name Lorentz transformations, although they predate Lorentz. But Lorentz was quite a significant scientist, and he's written about this. And he was looking at the changes that occur, things like length contraction, are actually contractions of the nucleus of the electron owing to forces and so on. You know, he wasn't talking about just apparent effects. And he did have an ether. He didn't abandon an ether, a means of a medium in which electromagnetic radiation would actually be transmitted through the normal wave phenomena. So Lorentz Ether Theory has been considered by a number of people, and it's actually an interesting phenomenon in itself. I think, unfortunately, it's been neglected a lot. But in my discussions with Stephan, we were talking about maybe filling some of these gaps. And Stephan and I have agreed that he would actually look at Lorentz Ether Theory, because some people say, well, maybe Lorentz transformations a la special relativity are incorrect, but maybe Lorentz Ether Theory is a preferable theory to adopt. And so he's going to look to see, is it preferable? Is it not preferable? Does it accord with scientific evidence, to wit, experimental evidence, or not? He's going to look at many of the experiments which actually he has addressed before, like the Michelson-Gale, the Wang 2003 experiment, GPS clock operation, GPS clock synchronization, and application of the correspondence principle. So I think I've said enough. I want to allow Stephan to come in now, and people are beginning to come in. So Stephan, you're up now, and you're very, very welcome. Thank you so much for coming back today.
Yes, thank you for having me. I'm glad to be here.
You're very welcome. Our thanks are to you. So what I'm going to do now is I'm going to put up, because we did a rehearsal about 5 minutes ago. Shall I put up your screen now?
Yes, please.
I don't think you have the slides on them yet, Stephan.
I do. Here they are.
So they're there now, yeah. So what I'm going to do is I'm going to take myself down, and I'm going to leave yourself in sole custody of the floor. And then as you talk, I'll bring your photograph down, so I'll maximize your screen, but you'll still have complete control. And then when you're finished, we'll come back. You know that there's no strict definition of the time available. We normally try to split the 2 hours into 50-50. I've absorbed about 5 minutes already. But if you want to talk for more than an hour, that's quite all right. If you want to talk for less than an hour, that's quite all right as well.
Yeah, so, I think the talk will last for about certainly less than an hour, Ian. So we will have enough time for discussion.
Oh, okay. Well, I was just saying to you, actually, I was a little disappointed 2 weeks ago, I think it was, where very few people were in on the social media. But I think the explanation for that was it was Labor Day in the United States. So I dare say we don't have it today. And in fact, I can see people coming in now. So I'm sure we'll have a very interesting conversation.
Good.
So the floor is all yours now, Stephan.
Right. Well, thank you very much again, Ian, for allowing me this opportunity to present about the Lorentz Ether Theory. I have, of course, in the past discussed special relativity. I have discussed the Galilean transformations. And I have also talked about the celery transformations, which I favor well. This morning, I want to address Lorentz Ether Theory, which there are some people who advocate for its correctness. So I am addressing that today. So the summary of my presentation, we subject the Lorentz Ether Theory to 5 tests. The first 2 tests are the 1925 Michelson-Gale experiment and the 2003 Wang experiment. I discussed those in the presentation. The second 2 tests are based on the very successful GPS and deal with clock operation and clock synchronization, those 2 aspects of the GPS. Incidentally, I consider the GPS to really be a game changer where these matters are concerned, and that they're going to usher in due course, a revolution in thinking about space-time physics. But to continue, the last test involves the application of the correspondence principle. Now, this isn't talked about a whole lot. It's certainly not in the discussions I'm in, but I think I'm introducing it because I think it is an important test that could reveal a lot about what is right and what is wrong. So we will have a look at that. I have mentioned it in the past in my work when I talked about the celery transformations. Well, I want to apply it here this morning to the Lorentz Ether Theory. So I argue that all 5 tests provide evidence against the Lorentz Ether Theory. So we'll see. I hope to justify that as I go along. So, of course, the central problem of relativity is to find the transformations connecting 2 inertial frames, an inertial frame S and an inertial frame S prime. In S, light speed is c, and we have the moving frame S prime moving in the way that we know along the x-axis at velocity v with respect to the inertial frame S. And as usual, in the normal way, we consider that at x equal to x prime equal to 0, well, that is, I should say, at t equal to t prime equal to 0, x is equal to x prime equal to 0. So that's where we start, when the 2 frames are coincident. And then as time progresses, the frame S prime moves to the right in the diagram at velocity v relative to frame S. Now, I heard somebody, I was looking at an old presentation, and I heard one of the attendees asking the presenter, why do we need Lorentz transformations? That was the question being asked because the Lorentz transformations form part of that particular presentation. And I wasn't satisfied with the response the presenter gave, but the whole idea is we need transformations to relate coordinates in one frame to those in another inertial frame. We're speaking about inertial frames. So that's why we need transformations. And the ones we normally, we are accustomed to certainly at low speeds, are the Galilean transformations. And we've been using those for, I guess, many, many years, maybe hundreds of years. We've been using the Galilean transformations. But we now need to move to some additional or new transformations, because the Galilean transformations have proven to be effective at low speeds. But when we get to high speeds, that is speeds that are comparable to the speed of light, then the Galilean transformations, as I showed in my last or one of my prior presentations, that the Galilean transformations are inadequate. So they are very good at low speeds, but at high speeds, they do not, for instance, give you phenomena like Thomas precession and other such phenomena, which have been confirmed experimentally. All right, so the central problem of relativity then is that we need to find transformations that connect coordinates in S to coordinates in S prime. That's necessary if we are to be able to analyze phenomena, natural phenomena. Now, the Lorentz Ether Theory, and that is what this presentation is about. This presentation is about what Lorentz had to say about these matters, and I take my information from his book, the H.A. Lorentz, The Theory of Electrons, the second edition, published in 1916, which is available on the internet. Excuse me. But he had published the first edition of this book in 1909. I have access to the latest edition, which is the 1916, and that's the final edition. He didn't publish a new edition after that. And in that book, he describes all his ideas. He goes on at length about a number of things with electrons and so on. He assumed the existence of an ether, and that, I guess, is what Lorentz, one of the things he's famous for, his belief in the ether, and his theory is developed around the existence of an ether. Good. So my presentation this morning focuses on Lorentz's ether theory. Now, he used three postulates. This is information coming from his book. He used length contraction, clock retardation. Those are two of his postulates that he used. And the third one was he assumed Einstein clock synchronization. That is, you synchronize clocks by assuming constant light speed for light traveling between those clocks. Now, I'll make a comment about this later on. It was a little odd that he did that. And I think that changed the course of almost history, because it led him now to these Lorentz transformations, which you see down at the bottom there, where you have, as I said, frame S, in this case, is the ether. In his theory, frame S, where we say light speed is c, he considered that is take that to mean the ether. So the equations you see there are equations connecting another inertial frame to the ether frame. And you see them there, the well-known Lorentz transformations. So Lorentz derived them using those assumptions, those postulates, the three of them, and he arrived at the Lorentz transformations, which is what they are called. So I believe there's a lot of history behind that. Ian was mentioning Voigt and Point, others did work and so on, but in the end, Lorentz is the name given to these transformations. Now, mainstream science today considers that the Lorentz ether theory is operationally indistinguishable from special relativity theory. That's the view of mainstream science. I wouldn't give my view on that because I don't want to interfere with or corrupt what I'm going to say. That's the view of mainstream science. And coming out of that, therefore, you have 5 correct predictions of the Lorentz ether theory would be the transverse Doppler effect, relativistic beaming, Compton scattering, relativistic elastic collisions, and of course, clock retardation, which is one of the assumptions that was used to derive, that Lorentz used to derive those transformations. So you would expect that out of consistency, that it will predict clock retardation. So these are some of the correct predictions. I haven't worked on these, but these would follow from the idea that the Lorentz Ether Theory is operationally the same as special relativity theory, according to mainstream. But I move on from there. I have applied 5 tests to the Lorentz Ether Theory. The Michelson-Gale experiment, the Wang experiment, the GPS clock operation, and this should be interesting, GPS clock synchronization, and as I said, the correspondence principle. So let's go to the first one, the Michelson-Gale experiment, a well-known 1925 experiment. And I continue, I've said before, and I continue to point out that I have never seen this in a special relativity textbook. And I've looked at many, but I can't say it's not there because I haven't looked at all, obviously, all special relativity textbooks. But it is extremely rare that you don't find it in special relativity textbooks. But pardon me for mentioning that. We're talking Lorentz Ether Theory this morning. So the Michelson-Gale experiment, this is what you see there is light beam is projected from a source S, and it goes around from S, from A to B, C, D, and back to A into an interferometer A, sorry. These are all mirrors that direct the path of the light, and then the mirror also direct the path of the light in the opposite direction. And then they interfere, and you have an interference pattern at the interferometer I. This dotted line here is a smaller path that provided a reference point to know how much fringe shift there was. So we don't need to consider this at this time. It was really a very clever idea that Michelson came up with to allow them to see the fringe shift. So this is the formula here, that the fringe shift delta is equal to the time difference between those two beams, delta t prime, that is the difference in the clockwise and anti-clockwise beams on this going around this rectangle, times the speed of light over the wavelength of the monochromatic light that is used in the experiment. And we get this formula here where omega is the angular velocity of the Earth, A is the area of the rectangle, and phi is the latitude, the latitude of the experiment. Good. And this, of course, has been confirmed experimentally in 1925 by Michelson and Gale. It's a really wonderful experiment. Consequential, I would consider, but we are applying the Lorentz Ether Theory to this. Now, if the theory is being tested by applying it to this experiment. So what I do is, I want to know, in order to determine the speed of the time to travel around the rectangle, the arms of the apparatus, we have to know the speed of the light in the apparatus. And the Lorentz Ether Theory predicts that the speed of light, and we did this calculation before in other circumstances, but I'm doing it here for the Lorentz Ether Theory this morning. You take the Lorentz transformations and you take a small change, and you simply divide the small change in the moving frame to the time in that frame, and we get, when you carry out this very elementary calculation, you get that the speed of light predicted by the Lorentz transformations of Lorentz Ether Theory to be c. Now, others have argued with me about this, but no one has shown any error in this analysis. And this is the model that represents Lorentz Ether Theory, where S is the ether. So those who wish to disagree can't simply say I disagree, but need to show what is the error in this analysis. And it is very elementary analysis, so any error would be very easy to find. So using that light speed constant c, we have constant light speed in all the arms of the apparatus. So in either direction, clockwise or counterclockwise, there's going to be a 0 time difference and therefore 0 fringe shift. And this is what the Lorentz Ether Theory predicts: a 0 fringe shift in the Michelson-Gale experiment. Therefore, the theory fails because it is making an incorrect prediction. The actual fringe shift is, as we saw earlier, given by this formula that has been verified by the actual experiment. So this is the first test, and the theory fails. Now, that is enough to discredit the theory completely, that we need to, it's just invalid, but we're going on to do 4 other tests. So on to the second test. This is the more recent 2003 Wang experiment. This is a really, really clever experiment that was performed by Wang and his associates, where fiber optic cables were moved around using these cylindrical pulleys, I should say, these pulleys, and you move the fiber along rapidly. Now, this FOG, I think, means fiber optic gyroscope, but here is where you have the source and the detector moving with the fiber. So all of this is in the frame of the moving fiber. And in there, when they performed this experiment, they got, again, light moving in 2 directions, with the movement in the direction of the moving fiber and in the opposite direction. And there was a time difference between those 2 beams, given by 2LV over C squared, where L is the total length of the fiber and V is the velocity of the fiber, the uniform velocity. Now, this has been confirmed experimentally. The experiment has actually, been published back in 2003 in a mainstream journal. And one of the features of this result is that the time difference is independent of the refractive index N of the medium. So whatever theories to explain this must get this result, where you don't have N in the result and you get this formula, basically. And this, as I said, has been experimentally confirmed. There's one paper I'm aware of that tried to explain this formula using standard theory. However, the problem is that they calculated the time difference in the laboratory frame and not in the moving frame. And they did that for a reason. But anyway, so let us now apply the Lorentz Ether Theory to this. Here's what the first thing we have. Now, Fizeau, back, I think, was it 1851, established this formula for light speed in a moving frame, a moving optical medium or moving medium, where you have light traveling through that moving medium. If the light is traveling in the same direction as the moving medium, then the velocity of the light in that medium, with respect to the laboratory, so I call it C lab, and the plus sign indicates it's moving in the same direction as the medium, is given by this formula. He established this experimentally. So however he came about it, and we don't have to go into that, this formula has been experimentally confirmed. Now, the Lorentz Ether Theory has this formula as its velocity transformation, where it transforms. I won't go into the derivation of this. It's a straightforward derivation, actually, to go from the ether frame to the moving frame. And in this case, we're going to take the lab as the ether frame, approximately. So the velocity in the moving frame given by U prime is equal to the velocity in the stationary frame or the ether frame, which is U, minus V over 1 minus VU over C squared. So we take this formula here for the velocity in the lab frame. This corresponds to U. So we stick this here into the formula for U. Here it is. U prime is equal to this formula, C over N into 1 minus 1 over N squared all times V, minus V over 1 minus V times U over C squared, where U is this term in here, which is the formula confirmed by Fizeau. And when you work through the analysis with an approximation, because for using eliminating second order terms, you end up that the velocity of the light relative to the moving frame, in this case, the moving fiber, is C over N, where N is the refractive index of the fiber. So this is what we end up with. So the speed of the light, according to the Lorentz Ether Theory, in the moving frame, with the light traveling in the direction of that moving frame, is C over N. We go in the other direction now for the Fizeau formula for the speed of light in a direction opposite to that of the moving frame is given by this. You change a sign here. The formula for the velocity transformation from the Lorentz Ether Theory is given by this, where the negative sign that we had before, we had mu minus v over 1 minus vu over c squared. Now you have a plus sign. So you take this, stick it into here for u and here. And when you work through the analysis, you get again that the speed of light relative to the medium for the light moving in a direction opposite to the moving medium is C over N as predicted by the Lorentz Ether Theory. Now, we therefore know what the Lorentz Ether Theory says. These Fizeau formulae transform to the moving from the lab frame to the moving frame and become C over N. And now we apply it, therefore, to the Wang experiment, and we get that. I still put this back here to show you that this is the lab speed of light, the speed of light relative to the laboratory from Fizeau. This is the speed of light relative to the medium, the moving medium, according to the Lorentz Ether Theory, which is C over N, and therefore the time difference between counter-propagating beams moving in opposite direction, would be the length of the fiber divided by C over N in one direction minus the length of the fiber L divided by C over N in the opposite direction, and you get 0. So a constant light speed, C over N in the moving medium, results in 0 time difference. And therefore the theory fails again, because according to Wang, the time difference between those two beams is 2LV over C squared, which has been experimentally confirmed. So that is failure number 2. Let us now go on to the GPS clocks. We're talking here about GPS clock operation. And I tell you, the GPS system has really been a revelation, at least for me. Here is clocks moving according to the GPS literature, and I'm referring, I've done this before, Ashby's paper, Living Reviews in Relativity in 2003, is a very important paper that everyone involved in this kind of activity and research should read. This is a formula he has in that book, which in that paper, I should say. Clocks moving relative to the ECI frame run slow. This is the formula here. So the integration of the path in the moving frame, integration of the time in the moving frame, is given by integration of 1 minus v squared over 2c squared, all into with respect to time in the ether frame, or in our case would be really the center of the earth. This is what the formula holds for. Good. Now the formula has a term involving gravitation. We are not considering gravitational effects, so I have eliminated those terms. So when you go to Ashby's paper, you wouldn't see the equation written like this. There will be 2 extra terms in there that have to do with gravitation and acceleration, which we are eliminating because we are not concerned about that aspect of the theory today. We are concerned really with the kinematics, what happens when there is movement. So this is the reduced formula here. If you take this formula, integrate over a short path, you get this simple derivation where we are assuming v to be approximately constant. So this will give us T prime is equal to 1 minus V squared over 2C squared into T. And this really could be written in this form. T prime is T over gamma. And we know we've defined gamma before, the usual gamma factor. And when you expand it, you see you get back this for V very much less than C. So basically, the equation representing the behavior of a moving GPS clock is T prime equals to T over gamma, certainly when V is very much less than C, which it is. So this is from Ashby's paper, and therefore this is an equation that defines the behavior of a GPS clock, one of those in those satellites that are moving around. So the GPS says the clock, this is the equation that governs the behavior of the clock. Lorentz Ether Theory says T prime is equal to gamma. This is the Lorentz time transformation here, which we can rewrite just by making a substitution here and just rearranging. We get that T prime is equal to T over gamma minus Vx prime over C squared. Now, clearly, this is not the same as this. This has this, the Lorentz Ether Theory time transformation has this additional term here. Now, it is unusual that some people see these two equations and say they are the same by putting x prime equal to 0 and just converting this to this. It's something that just defies reason, but some people do that. I know Einstein, when in his paper, he did something like that by putting one of the clock in the moving frame at the origin of the moving coordinate system, and therefore this reduces to that. But that is not legitimate in the sense that then this equation reduces to that for that single situation at the origin of the coordinate system, of the moving coordinate system, and nowhere else. And of course, that makes it useless in that scenario. Anyway, we can conclude this is what the GPS satisfies. This is what the Lorentz Ether Theory says the time transformation is. This is different from this. So this is a Lorentz Ether Theory failure. It is a transformation that is not confirmed by the behavior of the GPS clock system. Then there's the GPS clock synchronization. Again, Ashby's paper contains this information. This is a very important, another very important equation, which says that in the moving frame, which is on the surface of the Earth, the time, in this case, it's written as a differential. An incremental time is given by incremental distance over c plus 2 omega e, which is the angular velocity of the Earth, over c squared multiplied by an area shown in this diagram here. When the light moves, this is the area swept out by the movement of the light that is parallel to the equatorial plane. So this diagram attempts to show, to illustrate what's happening here. So the light is moving from 0 from here to some point here. D sigma prime is that distance. Theta is the distance with the horizontal, which is a line of latitude. O prime is the center of the Earth. And this is dAz prime here, which is the area being swept out. And d phi prime is this angle here. So that equation, again, is an experimentally confirmed equation. We don't have to concern ourselves as to how he got it. The GPS system confirms it every single day that it is operating, just as it did the one before. So we're going to, whatever theory you have, must be able to produce that result. So let's see if the Lorentz Ether Theory does that. So this is the GPS result here. It obeys this formula here. The Lorentz Ether Theory, where c prime, that is the speed of light in the moving frame, is c. Let us calculate dt prime in the moving frame. Well, it would be d sigma prime divided by c, because c is the speed of light in the moving frame as predicted by the Lorentz Ether Theory. Now, if you compare this with this, you see that this term isn't on the right here, is missing this second term. The Lorentz Ether Theory only gives you the first term. And Ashby has a fair amount of discussion about the problem with that. You're not going to achieve synchronization. To cut a long story short, you will not achieve synchronization of the clocks, which is what they use this for. It now requires a correction. Use of the Lorentz Ether Theory means you will require what they call a correction in Ashby's paper of this term, which really means using this gives you the wrong answer. So you have to add in this term to get the right answer. That's what they call a correction. Of course, you can clearly see that this fails to produce this equation. Therefore, the Lorentz Ether Theory fails the fourth test. So let's go to the final test. The correspondence principle. A new, more general theory must reduce to the old, more restrictive theory as a special approximation in the common domain of applicability. That is a summary of what the principle is about. So what it means is that the Lorentz transformations of the Lorentz Ether Theory must reduce to the Galilean transformations, which we know, based upon many years of experience, to hold at velocities very much less than the speed of light. And we're not going to zero because then we don't need transformation. So for this, satisfying this, these are the Galilean transformations. So the Lorentz transformations must reduce to these. These are the well-known Galilean transformations. We've discussed this in the past, and they are effective at low speeds, but I told you at higher speeds, they become inadequate. So let's go on now to see. The Lorentz transformations of the Lorentz Ether Theory are these, as we have shown before. They reduce to the transformations below for v very much less than the speed of light, since gamma goes to 1. So when you let v become very much less than c, gamma tends to 1. So this equation here becomes this. So the space transformation does reduce of the Lorentz Ether Theory does reduce to the space transformation of the Galilean transformation. But the time transformation does not. The time transformation of the Lorentz transformations does not reduce to the time transformation of the, here's what it reduces to actually. The gamma goes to 1, and you get to, this term here goes to 1, so you get t prime is equal to t minus vx over c squared. And when you compare them, they do not reduce to the Galilean, transformations for v much less than c, because of this term here. This term does not disappear. Some try to argue that, well, if v becomes very small, then this term becomes very small. But x could be large. You could make x large to prevent this term from becoming small. So I've actually seen in some books where French, for instance, in his special relativity textbook, he constrains both v and x to ensure that this term becomes small. But that is not legitimate. You can't constrain x. You're saying that this must reduce to 0 for v very, very small. But if you have to put constraints on x, then you're not reducing and becoming like the circumstances for or that accompany the Galilean transformations, where there's no x restriction. In the Galilean transformations, there's a restriction on v. We said they operate well at low speeds, but any x. So that's the problem. The Lorentz transformations do not reduce to the Galilean transformations for v very much less than c. And there's a little proof in this paper, although the proof is concerned special relativity. I I consider that it applies here as well. I have actually done the analysis myself, but I'm referring you to this interesting paper for some more discussion on this matter. So here's what we have, everyone. We have 5 failed tests of the Lorentz Ether Theory. It fails the Michelson-Gale experiment. It fails the Wang experiment. It fails to define GPS clock operation. It cannot produce the GPS clock synchronization algorithm. And it fails the correspondence principle. Now, only one of these failures needs to occur. Only one, as we know. As we know, you can pass 1,000 experiments. If you fail one as a reliable test, and it fails that test, then the theory has to be rejected. So but here we have 5. And I believe there are others, but I have selected these 5 because I think them very clear and easy to digest. So I go to a historical note. Lorentz used the 3 assumptions, and I mentioned I would come back to this. If Lorentz had used just 2 assumptions, and let me hasten to add, I've done the analysis myself, and I've seen Celery actually did this analysis also. If he had used just length contraction and clock retardation and omitted Einstein clock synchronization, he would actually have arrived at the Celery transformations in 1909. That's the first date when he published his book, so I'm using that date when he published his book describing his use of these 3 assumptions and arriving at the Lorentz transformations in his Lorentz Ether Theory. If he had done that and not used Einstein clock synchronization, and it's not clear to me why he did that. Maybe he was influenced by Einstein. I don't know. Because before 1905, Lorentz had arrived at the Lorentz transformations by using this idea of covariance, where the electromagnetic equations for electromagnetic waves must retain the same form when you move from one frame to the next. But then he later, after I guess Einstein published his paper in 1905, Lorentz appears to have been influenced, others may know more about that than I do, by this Einstein's theory and this clock synchronization that Einstein adopted. And he included it and arrived at the Lorentz transformations. But as I said, if he had omitted it, he would arrive at different transformations, the Celery transformations. In fact, Celery used clock retardation, just like Lorentz did, but he used two-way light speed constancy, which had been established much later. And he arrived at what I refer to as the Celery transformations in 1995. And I believe these are the correct transformations that connect one initial frame to the other. And if you notice, the Lorentz Ether Theory has an ether. The Celery theory also has what you may refer to as an ether. I prefer to use the term preferred frame, which basically corresponds to the ether. So they're very similar, but because Lorentz used this Einstein clock synchronization, he arrived at a different time transformation than Celery did. But the two theories are really very close, but for that term, which they're very close in one sense, conceptually. But in actuality, they're quite different because they make a completely different, a number of different predictions. One of which, of course, is the speed of light in the moving frame. The Lorentz Ether Theory predicts constant light speed c, though the ideas behind his theory involve variable light speeds in the associated with the ether, and that's another thing that perplexes me. His ether theory doesn't accord with the idea of a constant light speed coming out of the Lorentz transformations, and I don't understand why he didn't see that. Anyway, so I move on to say that the Celery transformations pass all of the experimental tests. I have subjected them to a whole battery of tests for many months into years. I have described at least 18 of them I've written up and put in an email group to which I belong. And I have since gone beyond that and tested them. Every single bit of test or experiment I see, I apply the celery transformations, because that is what you have to do. If you're going to propose a theory to replace the existing one, you need to show that the one you propose passes all of the existing tests. And it would help if it explains some new things that the existing one does not. And the celery transformations do that as well. I am quite convinced of their correctness, but continue to be open to comments about them or objections, because we want to verify, I want to verify their correctness. But as of today, I consider the Lorentz Ether Theory to be wrong. I believe I've demonstrated that. And I'm putting to you that the celery transformations, which Lorentz could have arrived at if he did not use Einstein clock synchronization in his development, the celery transformations, I believe, are the correct transformations that connect two inertial frames. So I wish to end there and thank you very much. Ian, you may come back in now.
Okay, thank you very much. I'll just bring the main screen down. Many thanks for that very clear exposition, and you've gone through those tests quite clearly, and you've shown the consequences of assuming the Lorentz Ether theory and using the transformations and so on, and compared that with experimentation.
Yes.
It seems to be, with regard to today's exposition, Stephan, I know you've given some other experiments. You've talked about 18, I think, there, and you've actually talked about many of those in previous talks, and we can yes. look at the recordings of those and go into those. Yes. But as regards to the 5 tests today, it seems to me that all but the clock ones, in other words, the clock operation and the clock synchronization, in other words, the MG, the Wang, the correspondence principle, all those would be met by the Galilean transformation. And because the problem seems to be arising where you calculate the speed of light to be invariant, based on the Lorentz transformations. And this obviously doesn't occur if you take the spatial dimension out of the time transformation. But one might say, maybe just to start conversation, we'll deal with the questions now. One might say, well, these clock matters are really dependent upon the way that atomic clocks, say cesium clocks, would operate, and the frequency of vibration and so on. And they're not per se, perhaps, matters for transformation. Would that be something that you would gainsay, or could it be argued that way?
No, I wouldn't put. They are a matter for transformations, because the clocks on the satellites are in a moving frame. We on the Earth, and let's just assume we are at the North Pole, the center of the Earth, so we don't have to take other factors into account. We want to know what is the relationship between our clocks on Earth and the clocks on the satellite. So the clocks on this, that relationship is what I derived in the exposition. T prime on the satellite is equal to T on the ground over gamma. In other words, the satellite clocks run slow, Ian, relative to the clocks at the center of the Earth. And that's what the transformations provide for us. Sometimes I guess some of these things is not quite obvious why our transformation would apply, but I think I have just explained that the time on the Earth has to be related to the time on the clock, and in fact that's how we quantify the clock slowing on the satellites, to be able to work it out to what it is, so we could ensure that the clocks in the satellites stay synchronized with the clocks on the Earth. It is because we know that relationship. Yeah.
Yeah, I quite understand that, and thanks for explaining that. I suppose just one more point, maybe before we go to the questions, is I've no experimental justification for this, but I'm just hypothetically posing the possibility that suppose one had some other form of clock, and one found that it didn't behave exactly the same way as these atomic cesium clocks behaved. It had this clock retardation plus or minus some other effect, which might be caused by physical means, which wasn't merely a transformation effect. Do you think that might be possible?
I guess so. I guess so. I think I saw a discussion about, pendulum clocks and even like what you call it, those clocks with the
like sand clocks or something.
The sand clocks, yes.
Clock, yeah.
I really couldn't comment on those. I don't know. My answer to your question is I do not know how. If in fact they don't satisfy the transformation, if it doesn't apply to them, then that could possibly be. My analysis has to do with where they have observed that there is clock slowing, and that happens with these atomic clocks. But these other clocks, Ian, I'm not sure what the situation would be with them.
And you correctly stated, Stephan, that you're dealing with GPS clocks.
Yes.
So that's fine. That is true. So maybe we could just briefly go through some questions here. There some, I think there was something here. Let me see. Just maybe very basic. Just asking you to define an inertial frame. Let me see. I think it came from Toby Grotz. Here it is. Yeah. At the beginning, he just said maybe define what is an inertial frame.
Well, I took that that everybody knows what an inertial frame is. It's a frame in which, well, as they put it, that obey Newton's laws, especially the first law where there are no forces involved. So it's a frame in which is either stationary or moving uniformly and undergoing no acceleration whatsoever.
Oh, okay. Well, that's just reiterated a basic principle, just to make sure that.
Ian, I'm seeing two questions coming up in the studio chat. Shall I turn to
you? Have I not closed down one of them? I'm sorry.
No, I see.
I see nothing at the moment. Sorry. You mean in the chat?
Yes, in the studio. What it says is studio chat.
Private chat.
Yeah.
Well, thank you very much for looking at that, Stephan, because you have access to that. But most people don't. So with your permission, what I thought we might do is we might go through the main chat. I think there might be half a dozen questions there. And then we'll probably bring Jim in because he's in the green room and he can actually pose those points. But thank you for reminding of those.
Yeah, excellent. Sure.
Okay. So let me see what the others have said. Again, mainly chat between people. Yeah, I don't know. This is just a comment from Kurt Renshaw. GPS clocks on any given satellite should run slow compared to a clock on any other given satellite, according to SRT. Yeah, we're probably challenging that. They should not be able to be synchronized at all, since the velocity relative to any sat changes constantly in this constellation. Yeah, we probably agree with that. You would agree with that, wouldn't you?
I wouldn't disagree. Yes, the SRT does run into that problem.
Yeah, it's sort of a problem which would seem to indicate that GPS by its nature couldn't work if SRT were true.
Yeah.
Okay. But I don't know. He thought maybe he wanted your view on that. Maybe he thought you'd glossed over it in the past. So we got your view on it.
No, I was staying away from special relativity this morning, because sometimes when I've challenged Lorentz Ether Theory in the past, I have been accused of using an SRT interpretation. So I try to avoid talking about SRT this morning and to place the lecture firmly in the camp of Lorentz Ether Theory. That's why I stayed away from that. Largely, I think I mentioned special relativity a couple of times, but largely I tried to stay away.
Well, that was the purpose of today's discussion, to address the non-relativistic, non-special relativistic Lorentz transforms. Yeah, but the same point I think is made by Renfeld Spanish. He just says it's silly to say the clocks run slow and then there's reciprocity. That's all he's saying there. So.
Well, do you understand that, Ian? Could you bring it back up?
Yeah, I'll bring it back. Sorry, I'm being a bit quick. He's just saying it is silly, in my opinion, it is silly that GPS satellite clocks run slow with reference to Earth-based clocks. The Earth-based clocks should also be running slow compared with satellite clocks. Well, I take it he's talking in terms of SRT there. So,
okay. Just to be clear, I wanted that to be clear.
You flashed it up too quickly. I want to make sure that you agree with me.
Sure, yes. In an SRT interpretation, because the celery transformations is asymmetrical clock slowing. The ones in the satellite run slow, which is relative to those on Earth, but not the other way around. Absolutely.
Yes, right. Okay, now let me see any other questions we can deal with. There's a lot of chat here. Well, maybe, you see, he's come back again, Kurt. You're saying exactly, discussions here. And each sat clock runs at varying rates compared to any other clock, but they don't. Well, this is presumably, again, if it were in terms of SRT. It is said that they are all synced to a mythical ECI clock. Well, that's why I put up this this comment of his. Have you any comment on that? He talks about the ECI being a mythical. I mean, it's an operational frame.
Well, I guess he calls it mythical, but the clocks at the North Pole, and then there's a place on the Earth called the geoid. I think it's Geoid. I think it's spelled, where the clocks all behave as though they are the center of the Earth, and that the clocks in the satellites are running slow relative to that clock. But I don't think it's fair to say it's mythical, because we do have places on Earth where we could in fact compare. The comparison is valid between moving clocks and a stationary clock on Earth. But I guess we're not far off, Ian, from what he's saying.
No. I mean, for my humble part, I might say, well, I'll bring the word ether in there. I'll say there's an ether frame on the Earth, which is basically carried by the Earth in its gravity.
Basically, and that's what he's saying, the ECI clock, a clock stationary in the ECI.
Yes, yeah. Okay, now, they should be seen to me. Well, just to follow on that, he then says, this just ignores time dilation as should be seen from each sat to each other in SRT. Again, I think he's just really indicating what would be the consequences of SRT.
Yeah.
Which we probably agree with.
Yes.
Okay. Just make sure we're not missing anything before we get to the okay. You've kept out the gravitational acceleration. You said that earlier on. There's two. I'm not quite sure what's going up there. There's some further discussion which is not very much relevant. It may be going on to other matters, but well, that's just in terms of SRT. Okay. Well, just to highlight it, because I've glossed over it, Toby Grotz has just asking you directly, Stephan, what is the speaker's, your position on the existence of the ether?
I believe there is some kind of an ether in existence. I really do believe that. I've done a lot of work on that in the past. But because I've become aware of the existence of the ECI frame, the Earth-centered inertial frame, which is a frame that moves with the Earth but doesn't share its rotation. I see that, and then there is the sun-centered inertial frame, and we've talked about the hierarchy of inertial frames that could possibly exist. So, and it is there where I'm trying to understand or determine the relationship between these different inertial frames. So, to answer this question directly, I do believe in the existence of some kind of ether. I do. The closest I believe we have come to that is the ECI frame that the GPS system operates with. That is critical to the operation of the GPS. And which, by the way, I remember hearing in a presentation, Jim Asden talking about the elephant in the room, and he thought the elephant in the room was the Michelson-Gale experiment. The elephant in the room is the ECI frame, which directly contradicts special relativity. You wouldn't see that discussion in any books. Special relativity prohibits the existence of a preferred frame like an ether, as you know. And the ECI frame is a preferred frame that is used in the operation of the GPS. So that is a direct violation of special relativity, and it really, they can't go together. But I believe that is the closest that we have come to the existence of some kind of ether, Ian. So I move beyond just a universal ether to a more nuanced situation with, now we're talking about an ECI frame, which has properties of an ether because there the light speed is c, and light travels in there at light speed c and behaves like an ether. But then there is this sun-centered inertial frame where light in that frame travels at the speed of c as well. And there are equations describing that behavior. So it's a little more involved now beyond what was historically be considered to be this universal ether, which is this luminous
stationary, absolutely stationary.
Yes, sure. Sorry, I was a little at a loss for words there. But I think the ECI frame comes closest to what I consider to be an ether. Yes.
Well, actually, Jim has a question there, which I was just about to bring up, but he's entered the green room, so I might wait with your and his position. Anybody in the green room, I'll ask him to come up directly.
They call it the luminiferous ether. That's what I was struggling with there. The luminiferous ether is how they used to call it. Yes. Mm-hmm.
Which is a bit tautological, because ether just comes from light burning or some burning.
Yes.
It produces light. Luminiferous is light carrying. So.
Yes. Okay. Sure.
Now let me see. Please address the issue of. Yeah, I think they're asking about. Some people have talked about 2 light speed limits. Okay. We're talking about various papers. Jim, I'll bring Jim in on a couple of points he's made about. He's asking about Solari transforms, second order, and so on. We'll bring him up in a moment. And Sanya correction. Yeah. Okay. So I think we've disposed of those now. We have a number of our regulars here, and I'm delighted to see them. And we do actually have a number of our regulars obviously watching this. They're participating through the Facebook and YouTube. They haven't put questions up. If they want to, that's fine. Jim is one of our regulars, and he's got a very incisive mind. And I'm delighted, as usual, that he's put a few questions in. Yes. So, however, the penalty for putting those questions in is he'll be the first to be asked to come on stage. So Jim, you're very welcome to today's talk.
Hi,
you
Jim.
Had about 3 questions there.
Hi, Stephan. Well, first thank you for your very clear presentation. Mm-hmm. You're a very articulate man with a great mind, and I appreciated your presentation a lot.
Your voice is a tiny bit low, Jim. Only a tiny bit.
Can you hear me better now?
Yes.
That's better.
Okay, it's raining a little bit, so there could be some background noise. And
We're hearing
that's
you.
why it's a little dark, because I rely on window light. I could turn on the light, but then that's too much. At any rate, I'm wondering about, to quote you, you said how we quantify, quote unquote, the orbit clock slower. I find it hard to believe that the GPS system depends upon the kinds of Lorentz transforms or Solari transforms, as you may wish, that you describe. I look at it more as a calibration problem, that you have I don't even know why all these transforms are even brought into the picture. It's a huge machine. You have a control center. You have signal generators on the Earth's surface at known locations. You can calibrate the whole thing by twisting a few dials, figuratively speaking. Okay, in other words, these would be changing parameters in your system to essentially calibrate it so that it gives you the correct answer of where a known signal generator on the Earth's surface is located. And if you have enough of these signal generators on the Earth's surface at known locations, you can then just simply twist a few dials, again, figuratively speaking. Actually, you'd be changing some parameters of what clock speeds actually are or should be or whatever. And that's just simply a calibration problem. Just like any other equipment would be calibrated to give a correct result before you actually use it, to make measurements from other signal generators at unknown locations to determine what their locations are. Are you getting the drift of what I'm saying? Now, I've raised this question.
Yes. Sorry, go ahead. I was waiting to respond.
This question before in a previous talk of yours, and you honestly said that you really didn't know what the procedures are that they use, which is a legitimate, correct response. It's always okay to say one doesn't have the information. But I find it terribly, given the importance of GPS, I don't see why this is not viewed as a simple calibration problem. And I find it hard to believe that people actually use some of the equations that you presented to calculate how the system should operate and set it operating in that way based upon Lorentz transforms of reference frames. So is that a question that I'm asking? I think it is.
Okay, I can respond, Jim. I don't remember our prior discussion. You said I wasn't able to answer. If I'm not, I would indicate, as you said I did. But on this occasion,
I was just talking about what the procedures actually are. Do they sit and calculate with regard to reference frames and tweak the system that way? As one might think.
Just let him answer that, Jim, and we can come back if you wish. So, Stephan, yes.
Yes. So what you described there, Jim, sounds like trial and error to me. When you talk about calibration, you adjust some knobs and wait until you get synchronization. That's trial and error. Now, that could work, I guess, if you want to do that. But if we have a defined procedure that we know the system obeys, then that's the one we choose to use, because it will save us a lot of time and effort. Instead of trial and error, we try until we get synchronization. What they do now is they are aware, they can quantify the slowing of the clocks, just as I indicated. They know that the clocks, and I showed you the equation, they know the clocks slow by a certain amount depending on their speed relative to the Earth's centered inertial frame. So that means, in fact, I think it turns out per day, the satellite clocks is about, I think it's 7,214 nanoseconds per day. That is then pre-programmed into the clocks before they are launched. They speed up the clocks on Earth so that when they get into orbit and they experience the slowing, they will slow and start to tick at the rate corresponding to those on Earth. Of course, we're not talking gravity. Gravity is another issue.
Sorry, I don't mean to be impolite, sir, but how do you pre-program a cesium atom?
No, they have a program. There's a crystal.
I mean, you just said that they're pre-programmed before they're set into orbit. And how do you pre-program a cesium atom?
Yeah,
a cesium atom.
I don't know that's quite what he said. So let's hear, Stephan. What did you say?
Jim, no, I believe it was. All right. There's a crystal from my reading, and if you read the defining, not even Ashby's paper talks about it. How the clocks operate and the great details about how the actual clocks operate. I haven't gone into that theory in any deep way because I didn't feel I needed to. But there's a crystal which defines the rate of operation of the clock. Good? And you can adjust that, the crystal frequency to change the rate of operation of the clock. And in fact, I did a paper, and I could circulate it if you wish, in which I show how that frequency, and it's on. There's a calculation online, but it's not very clear. My calculation, I think it's clearer than what I see online. But you asked the question, how do you pre-program this cesium clock? Well, there are methods to do that. This crystal, which defines, just like in a computer, Jim.
But the operational objective is not to set cesium clock rates. It's to get accurate position coordinates.
Jim, we talking at cross purposes here. This stuff we are discussing here is well defined and written out. You know, there is not a question of opinions on this matter. They adjust the clock rate by using this crystal frequency, and if you adjust the frequency appropriately, you can change the rate of operation of the clock. Now, the mechanics of that, I really am unfamiliar with that, and I really chose not to go into that because it's not necessary for me to use the clock. I can use the clock and how it operates to do what I want to do, which is to test the various theories and so on. So
but the whole point is not to tinker with cesium clock rates. It's to accurately determine the position of a signal generator on Earth.
Yes,
the signal generator is our automobile riding along a road somewhere. And if we know where that signal generator is,
Jim, we know that. We know that.
Jim, excuse me, Jim. Part of being able to do what you just described has to do with having synchronized clocks. You have to have that. Then there's something called the range equation that comes in that allows them with this, when they have these 4 satellites and they have this triangulation to determine position and so on. It's a little bit more involved than you are describing. But you have to have synchronized clocks. That is fundamental.
I'm not denying theoretically that so-called synchronized clocks are an important feature of the whole system. I'm not denying that at all. What I'm saying is that the goal is accuracy of the system in locating an object, generating a signal, such as an automobile traveling along a road. And to me, that's a calibration problem.
No,
you can leave the physics out of it completely.
Yeah, I disagree with you.
Physics out. You just want to know, is my system accurately locating an object, a signal generator at a known location? That is your criteria, not whether clocks are synchronized or whatever.
No, but Jim, Jim, doing that, you require synchronized clocks. If you want to tell the correct position, you have to have accurately synchronized clocks. Well, I don't understand why you're not seeing that point. That is a critical
I'm not denying that you have to have synchronized clocks. What I'm pointing out is that the objective is accurate location of an object on the surface of the Earth. And that would be a calibration problem.
Okay,
you calibrate your equipment
if I may just
so that it gives you accurate
Jim,
location of a known object.
Yeah,
of an object
Jim,
of a known location.
Jim,
yes, sir.
Jim, please let me speak. I may be obfuscating the matter, and I rely upon you gentlemen to correct me if I am. But it may help if I say this, that what I have found quite intriguing is that the GPS engineers get the thing working. You get an accurate position of an automobile on a road or whatever, where you want to go. Now, so they make corrections to the clock rates, and they make a correction to the algorithm, which has a Sagnac correction in it. Now, that flies in the face of existing theory. So if they were flying, Stephan, I think, has shown this actually. If they were using existing accepted theory, which they all claim to adhere to, they wouldn't put that Sagnac correction in, and they wouldn't. I don't know. They put in a modified form of clock retardation with the spatial coordinate in. They don't do that. They get it working. But so you're right. They do calibrate it to make sure that it works, and they're experienced people. There are probably not many theoreticians there. But if we're studying fundamental science, we want to be able to see how this works. We want to be able to predict it. And that's what Stephan is doing. So I don't know if that helps to maybe bridge the discussion between you at the moment. I think you're looking at the same problem from different ends.
Yes, thank you, Ian. I think what you're more articulate than me in pointing out what the issues really are. And I appreciate that. Whoops, that's some thunder here. I don't know whether you heard the Big Bang.
Well, it was
my last point,
message from up on high.
Yeah.
My last point about is actually an attack, not necessarily against the LET, and I agree with what Stephan has said about its fails, but perhaps an even more fundamental critique of the Lorentz transforms in general. Perhaps the major fail is use of time as both an independent and dependent variables, contrary to the scientific method. In the transform, time is used. And so therefore, and then the claim is made that the laws of physics are going to be now invariant across this transform, in which time is used as a spatial dimension, or a proxy for a spatial dimension. Well, the problem there is that there are no laws of physics anymore, which involve time, and they all do. And so, in other words, you can't have time in your transform as well as defining laws of physics. Even all of Maxwell equations, even where the variable t for time is not explicit in the equation, time is still there. Like, for example, if the div of a field is equal to 0, well, that's assuming that it remains the same over time. And so basically, there are no laws of physics to be invariant across a transform in which time is used, as in the Lorentz transform. And so the whole thing doesn't make sense. And perhaps that's the major fail of all. End of speech. Thank you.
Do you agree with that, Stephan? Because I think some of the things you've said could be interpreted as agreeing with Jim. In other words, you this deification of covariance, I think, is something that you question.
Yes, indeed I do. So there are elements of what he said that I think accord with my position on some of these matters. I certainly do not believe in Lorentz covariance. Having shown that light speed is not invariant, I believe Lorentz covariance collapses. I also believe, therefore, that space and time are independent instead of this four-dimensional thing that general relativity deals with, which I guess is where Jim was going with what he was saying. I don't agree with that at all. In fact, I think because of what happened with special relativity and the victory that special relativity had, and then it led to general relativity, that whole superstructure is built up on a foundation that is going to collapse, because space-time. There's no space and time are independent dimensions, if I may put it. That's certainly my belief. And coming out of my arguments against special relativity, and then my proposals with celery transformation, I am satisfied that space and time are independent, and therefore that whole space-time structure, which, by the way, is the basis of modern cosmology. Imagine that. Could you just think about that? Modern cosmology is built on a foundation of space-time physics being correct. You could imagine what that means if that collapses, that is that foundation, all of that stuff comes tumbling down. Wow, it's just unbelievable.
It means that binary mechanics wins the day. Well, I'm
may
glad
very
to
well
hear
do, Jim.
that I'm not such a black sheep after all in this whole story. Thank you, Stephan, and thank you, Ian, for helping clarify.
No, thank you for raising those
in
points.
a more articulate way what I was trying to say.
Yes, thanks, Jim.
Well, thank you. I'm glad I didn't misunderstand you, because I do know of those positions. You have raised some of those positions in regard to what Harry was doing with regard to trying to correct the transformations and so on. So I was aware of that. So is that everything that you those 3 points you wanted to make? Anything else?
Yes, for now.
If you want to come back, that's fine, Jim.
Thanks, Stephan, for a really crystal clear, and I'll say it again, a very talented, articulate speaker that Stephan is. Thank you very much.
Thank you very much for your feedback.
Thank you.
Now, I'm going to impose upon some of the others in the green room. The next person who actually made a number of comments was Jim Morrison. And I haven't brought them up, Jim, because I thought you might like to speak yourself
Jim
to them. Things like the second order effect and so on. So what are the points you were making, Jim?
Well, I'm not sure where to start, actually, but I still think it all goes back to MMX. And the fallacy or the mistake was that people assumed because it was so small that it was zero. But the GPS SAGNAC correction, with its velocity with respect to the velocity of a GPS satellite with respect to the ECI, shows that the Earth's rotation with respect to the ECI is the velocity that matters for the SAGNAC correction, GPS SAGNAC correction, and MMX. And that they were looking for the wrong velocity of the orbital speed of the Earth. What do you think of that?
Yeah. Shall I comment, Ian?
Please do, Stephan.
Yes. Thanks, Jim. Good morning. Yes, I do agree that the interpretation of the failure of the Michelson-Morley experiment led them, of course, to believe in constant line speed, which I believe to be false. And by the way, Jim, if they had taken seriously the Michelson-Gale experiment, which was not too long after, 20 odd years? No, a bit more than that. One was in 1887, the other one is 1925. They would have seen that the speed of light is not constant. So really, the Michelson-Morley experiment, of course, is a second order experiment, as you know. And you have pointed out that because of the ECI frame, they couldn't detect it because it really was something like maybe 300 or 400 meters per second was the velocity involved, which that equipment couldn't detect. But there are modern Michelson-Morley experiments, Jim, which go down to extreme levels of sensitivity, and they do not detect the movement of the Earth's surface as we rotate in the ECI frame. So I never really heard you comment on that. Why don't they detect it? Since you believe it's there, why don't these super sensitive modern Michelson-Morley type experiments, why don't they detect it? I would tell you why. I will give you my answer, but I would like very much to hear why don't they detect that movement of the Earth's surface, which they should, given the level of sensitivity. Could you comment on that?
Yeah, sure. In my opinion, the modern MMX repetitions that essentially use optical cavity resonators are looking for a velocity with respect to either the Earth's orbital motion or the Earth's supposed motion with respect to the CMB.
And also the rotational motion, Jim. Are they looking at the
they're not looking for that. In fact, they throw it out when they see it. They actually average their data because it's the effect is small enough that they can dismiss it. But they average their data, which is against the assumption of a universal ether, and actually suppress any signal that would be due to the Earth's rotation.
I see.
So there's one experiment, Stephan, which seems to bear up what Jim has just been saying, and I think Jim might quote this. You tell me if I'm wrong, but I think it's the Brie and Hall experiment where they seem to dismiss this 17 kilohertz signal or something as spurious. But if I haven't got the prime experiment incorrect, it was Aspen who then did an analysis. Right. Yeah, I'm right. He then did an analysis on that, Stephan, and he actually did get the speed of rotation of the Earth in Colorado or something, 455 meters per second or something.
350, whatever.
It was the 350.
465 is the maximum at the equator.
Yeah, that's right.
Right.
That's right.
Well, it's interesting. Let me make two points on that. One, as I said, Michelson-Morley is a second-order experiment. So it's not surprising that you have these minuscule signals, very small signals. And there are first-order experiments where the signal is much larger and that show that the speed of light is not constant. So I frankly do not see the need, unless it's a simple experiment, because Jim is proposing a multi-million-dollar experiment to go into space. Now, I guess if he could get Musk or somebody to give him some money, no problem. The more information we have, the better. But personally, from limited resources, I wouldn't agree to fund him because I believe the information he's looking for is available here on Earth with first-order experiments, such as the Michelson-Gale experiment, such as the use of synchronized clocks that you could measure the time for a signal to go from one point on the Earth to the other and see the change in light speed. So the Michelson-Morley experiment, assuming it works, isn't going to give us any more information than we have now, although, as I said, if you have the money and you could afford it, and you could try it out, the more information we have, the better. But I also want to make a second point, Jim. There is this confirmed experimental fact that the two-way transmission of light, the two-way speed of light is constant. So that, and I believe that operates in those Michelson-Morley experiments where the light is going back and forth and two-way light speed constancy has been experimentally confirmed, which would lead to the failure, I believe, is what is leading to the failure of all those modern experiments. Although you say it is that they throw the effect, I believe it has to do with the fact that two-way light speed is constant. So when these things go back and forth, you're not going to get the effect you're looking for because of that fact. Now, we could go into why that is so, but those are my 2 points about Michelson-Morley type experiments. One, we have first-order experiments that are superior in terms of the level of the signal and are available here on Earth. And two, the two-way light speed constancy experimental fact, I think, will work against Michelson-Morley experiments.
There is some debate, perhaps in the future, Jim, So, for example, if Stephan's second point is right, as distinct from the first point, which we agree with, I think we all agree with, the second point, that would seem to contradict or fly in the face of the Brie-Hall experiment, which actually got a difference in the two-way light speed because it found out what the Earth's rotational speed was by doing a two-way light speed analysis.
Yeah, that's the whole point of two-way light speed, is that the difference is so small that it hasn't been firmly unambiguously detected yet.
So what's the basis, Stephan, that you say it's zero? Like we might say it's very small. What you said there's experimental evidence to show it's
yes.
zero.
If you look at Zhang's book on special relativity and its experimental foundations, he goes through, I can't remember them offhand. No, I know they had to do with signals going out and back, but I think it has a lot to do with those Michelson-Morley type experiments. But it is now accepted today, two-way light speed constancy is an accepted experimental fact. So anybody who wishes to go against that will need to show, well, that's false, and proceed and show that, in fact, they're getting a difference.
Well, that's my whole point, is that it's so small that nobody's actually looked for it. Nobody's trying to detect the Earth's rotation on a second-order experiment. On Earth, okay. or in space.
Yes, well, as I believe I am going with that two-way light speed is constant.
Well, that's what screwed up physics from 19.
No, Jim. Ian, let me answer that. That is not what screwed it up. Let me tell you I told you what screwed it up. What screwed it up is that they deduced that the null result of the Michelson-Morley experiment means that the speed of one-way speed of light is constant.
Yes.
That is what screwed it up. No, but when they came to the Michelson-Gale, that clearly showed that the one-way speed of light is not constant. But they refused to change their minds because by that time, special relativity had gained all this prominence. They had seen light bending on the 1919 experiment where they saw starlight being bent by the sun, and Einstein became famous, and they discounted the Michelson-Gale. In fact, in Michelson-Gale's paper, they say in that paper that it not only supports ether theory, but the Michelson-Gale experiment supports relativity theory. That's what they say in the paper.
Maybe that was politically correct. They had to say
exactly.
that.
I think that is what happened there, Ian. I think that is exactly what happened. So Jim, I am saying what screwed it up is the deduction by science from the Michelson-Morley that one-way light speed is constant. They then ignored the one-way non-constancy of light in the Michelson-Gale experiment and went on the merry way, and that is what messed things up. But I don't think the way out of all of that is another Michelson-Morley experiment. I think the way out is really just recognizing that there are first-order experiments which show that this one-way speed of light is not constant. But we need to go beyond that. What has happened in the world, we need Ian and Jim to have a new theory to replace the existing one. They are never going to accept demonstrating that they will find a way to show you that the experiment is wrong, Jim. They will do that.
Well, I'm a proponent of King Chuan Tzu's local ether model. And I think you know a little bit about it.
Yes, I do. And I've studied some of his work.
And it explains a lot of stuff, including the dependency of atomic clock tick rate affect dependency on speed with respect to the ECI and altitude or gravitational potential.
The problem, though, is that Ian, Professor Tzu does not describe a set of transformations. Transformations are fundamental.
It's just a Galilean transformation.
No, the Galilean transformations, and I did a presentation on that. The Galilean transformations cannot predict Thomas precession, Jim?
Well, I don't know if he ever addressed that, but
I have.
That doesn't just
done
because there's one that there. We're saying there's alternative interpretations for a lot of different experiments.
Yeah.
Like
I
Gale,
talk about physical effects,
Keating and.
No, well, Jim, you can't because you can't simply ignore it. I'm saying you are believing.
I'm not saying you can't ignore it, but that doesn't mean that it's wrong because you haven't explained it. You haven't addressed it yet.
Well, until you do, you haven't made your case. Until you use the
you've made a case that it deserves to be more investigated.
Right. So I'm saying until you make the case.
Well,
listen, hear me, Jim, hear me. Until you make the case that the Galilean transformation could account for all of these phenomena, since it only accounts for a portion,
I disagree.
No
one person can explain everything in one shot.
Let me finish speaking, please. If you want to make the case for the Galilean transformations, as you seem to do, then you have to show that those transformations account not only for phenomena at low speeds, but also at high speeds. And until you do that, well, I'm afraid you just have work to do. I am saying, in my case, I have used the celery transformations to account for all of what the Galilean transformations account for, and for the others that the Lorentz transformations account for, as well as those that the Lorentz transformations do not account for. For example, Ian, the celery transformations accommodate superluminal signals. The Lorentz transformations cannot do that. They will run into causality issues where the event occurs before the cause. That's why...
Well, the Galileans probably would as well.
That's why mainstream science insists that you can't go faster than the speed of light. That is because the Lorentz transformations will have all kind of causality issues coming up. And there are other things. So I'm saying you have work to do, Jim. You have work to do. I think I am ahead of you because I have done the work and shown that the celery transformations could account for the whole set of phenomena and experiments. In fact, to date, I have not come across a single experiment or phenomenon which the celery transformations cannot account for. That's my bold claim on the program this morning.
Stephan.
I'm sorry?
You've done it very cogently and thank you very, very logically. However, we might just in passing, we probably don't have time to, because I want to bring maybe Vladimir in now, but perhaps the Bria and Hall experiment might contradict that. The other thing I might say is, you're looking at these other effects, which the STs do appear to be quite in accordance with. But as far as I could see, if you talk about composition of velocities, c plus or minus v, the Celeri, correct me if I'm wrong now, is only an approximation to that. You have a gamma squared coming in.
Yes.
Now, I know that's approximately 1, but if you could do a very, very accurate experiment to see whether, if you compose, say in a Sagnac type position, whether it were actually c plus v or it were approximately c plus v because gamma squared equals 1, that would maybe discriminate in another way between the two sets of transformations.
That's an interesting suggestion, but that would be, of course, a difficult experiment at those high speeds. But maybe somebody might think about it. But you're correct. It's not just c plus or minus v. There's a gamma squared involved there, yes.
So maybe we're back to Jim's orbital experiments,
well, no, his only second order thing. He will not detect that. His only second order. So he would, even at the speed that he's contemplating, I don't think he will see that effect. But then, and Jim, I want you to know that, as I said, so if you can get the money to carry out that experiment, go for it. I am in support. It's just that my view is that you're not going to find what you think you're going to find. So, and that we could find that effect here on Earth with experiments that we do have. But if you can get the cash to do it, go for it, my brother.
What? Let me just ask, what do you think would be the consequences if it did find a value, a speed equal to the low Earth orbital speed?
Well, certainly it will cause quite a change of views.
You don't think the GR people would say, "Oh yeah, we predicted that"?
They might, but
yes, we might all agree on that.
As for the celery transformation, right now, if that were to happen, I would have to say the celery transformations will have some work to do to explain that phenomenon, because right now, from Celery's papers and my own, the prediction, as I said, for two-way light speed is that all kinds of experiments where the light goes out and comes back should give a zero effect. And that is consistent with what, as I said, that's the accepted belief today, that two-way light speed is constant. But if you find an effect, I will have to sit up and take that very seriously, Jim, and go back to the drawing board with the celery transformation. So there we go.
So with a lot of people.
And so with a lot of people, sure. I guess so.
That's all we can expect, gentlemen. You know, you're totally open to that. And Stephan, having given all this experiment,
Ryan Wang also suggested that.
Yeah, he suggested what? That you have to go back.
MMX in space.
Oh yeah. Well, yes, I'm not quite sure what transformations he would adopt. He might be like me and adopt a Galilean system. But anyway, that's a bit more of another discussion. So, Jim, thank you very, very much for all those contributions and for putting it to Stephan, which he's dealt with very well.
Thank you. Thank you, Jim. That's spirited exchange.
Thank you.
Nice.
Yeah.
Now, we're running out of time, gentlemen, but Vladimir, I think he's been traveling a bit around the United States recently, but we haven't heard from him recently. Could I ask Vladimir, have you any comment on what Stephan has been talking about today, or you want to pose to him some of your work, how it fits in or contradicts it?
Thank you so much for your invitation. I have only one question. What is the wavelength for GPS? You're talking about some experiments with GPS. What is the wavelength of this radiation?
I don't know.
The wavelength that they use.
I'm sorry?
The actual signal that is sent, I don't know what the wavelength is.
But what is the correlation with speed of light? Because always I don't understand, what does it mean, speed of light? When you have your GPS, there is no light at all. And you are using this notion, speed of light, and I would like to find out, what does it mean?
Well, light is a form of electromagnetic radiation. So whether it's radio waves or whatever it may be, it's an electromagnetic signal. And so we tend to talk about speed of light because that's just the language that we use, but we mean any form of electromagnetic radiation.
But you know, there is no speed of light. There is a speed of electromagnetic radiation. You're right. But then it depends on magnetic and electric properties of the medium, or any medium. Ether, not ether, it doesn't matter. And there is a variation of these parameters. Let me remind you that there are some so-named fast radio bursts. They experimentally proved that the speed of electromagnetic waves different from different radio waves. You have your shorter wavelengths, you have your faster. Speed of electromagnetic waves depends on the wavelengths, on the frequency of your radiation. And it's
so
proved
already.
We could ask
Stephan. Vladimir, we could pose that question to Stephan. Do you perceive of a speed of electromagnetic radiation being frequency or wavelength dependent?
There is dispersion.
As far as I'm aware, again, if you read Ashby's paper, you will see the GPS system has to make corrections for a number of atmospheric phenomena. And they make those corrections. The idea is that having made those corrections, we consider, if those things were not there, the speed of light would be, the speed of light, we say electromagnetic radiation would be constant. But the presence of these different things causes them to have to make these corrections. I frankly don't concern myself with those corrections. I just consider that they have been made, and that the fact of the constancy of the speed of light as it travels through the ECI frame is what the GPS system depends on. And if that were not true, then the system will not function the way that it does. But there are these variables, and they take those into account and make adjustments and corrections to take them away from the overall effect, Vladimir. That's my understanding of how it works.
Yes, but my understanding that there is some plasma around Mother Earth. How to take care, how to have these corrections about this plasma, because there are variations in height, in everything, you know.
Yeah, well, those guys are experts. They have done it. And I really am not concerned myself with that too much. That they make the corrections is all that I am happy that they've made the corrections. But I can assure you there's something called the range equation in the GPS, where
okay, but let me tell you.
Just now, Vladimir, let me just say, where they, in order for them to determine the position of something on the surface of the Earth, that equation requires constant light. There's a C. So the distance traveled, speed is distance over time, distance is speed by time, and they use that equation. Now that equation would only function if indeed the speed of light or the electromagnetic radiation they use was constant. And it turns out that way, having made the corrections. So I'm satisfied with that.
I'm very sorry. There is no logic. You see what I mean? First of all, you told there is no change in the speed of light. And at the same time, you have to correct to achieve this goal, speed of light constant, taking into account this plasma around the Mother Earth. I'm very sorry. Where is the logic?
Well, see,
in
a way, if I may say so, Vladimir,
there is a plasma, there is everything, you know.
These are, yeah, okay. These are engineering problems, you know, to fine tune the system and take into account all these, you know,
no, it is principle.
But Stephan is more interested in the theory, the basic theory as to how we get these effects. As I said earlier, I'm actually quite interested in how the engineers have actually got the system working very accurately, and they put corrections in there, which their theories would actually appear to fly in the face of. It's like almost a double thing. So in a way, we're falling into that trap as well, because on the one hand, we're dealing with engineering problems, which you've raised, and on the other hand, we're dealing with you know, the physical theory. And with regard to these corrections, well, you haven't looked at some of those. You know, the main conclusion is that there is no ether in our space, in our world. And at the same time, we have to correct this empty space, taking into account this plasma around our Mother Earth. Look, where is the logic? The conclusion, the main conclusion, that there is no ether. And at the same time, part of the ether is plasma around our Mother Earth, and we have to take care about it. I'm very sorry.
Well,
okay.
Ian,
well, you don't use those terms. You talk about world universe model, and you talk about the material. So a lot of it is terminology. But sorry, Stephan, did you want to say something?
Yeah, I was just saying that. Well, I mean, I understand the confusion that these ideas are presenting for Vladimir, why he would disagree. But the fact is that the system works, and the basis of its operation has to do with the constancy through the Earth-centered inertial frame, which is like an ether, the constancy of electromagnetic radiation sent through that frame, having made for adjustments and corrections for all these varying effects, which you read about. But as I said, I don't go into that in detail, because that doesn't help me continue with my work, because it's just an interesting phenomenon how they do it. But they do, and the speed of that electromagnetic radiation turns out to be constant in the ECI frame, and that is the basis of operation of the very successful GPS system. So that's all I could say, Ian.
Well, thank you very much, Stephan. And Vladimir, we're running out of time.
Okay,
thank you.
Thank you very much.
Okay,
Ian,
we'll be able to
continue
talk
about this issue tomorrow. See you tomorrow, Ian.
You've just taken the words out of my mouth. I was just about to say that. Okay, thank you very much. We'll talk about this
thank you so much for good presentation, theoretical presentation, but I'm experimentalist. Always I'm looking for the experimental results.
Yes. All right. Thanks, Vladimir.
Corrected plasma changes in our.
Thank you. I'm sorry, we're just running out of time, so we're just going to have to stop. And we do have these slightly smaller, they're not restricted, but we don't have many participants, Sunday sessions. So I imagine some of the points that Vladimir has raised we'll discuss tomorrow. So, Stephan, what I'm going to do now is I've shut everybody off, so you won't be interrupted. I'm going to give you as much time as you want, some minutes, to summarize what you've done today, the response, anything that's arisen in the light of some of those questions, and how we might progress in the future. So I'm going to give you the complete floor just to summarize, and I'll then be back to close the meeting officially.
Sure. Yeah, well, thank you very much, Ian. I do appreciate the opportunity again to share these ideas. This morning, what we have been talking about is the Lorentz Ether Theory. And I think I have shown why that theory cannot be correct. And that's why really nobody practices it or follows it or uses it in today's world. The theory that is followed today is special relativity theory. That is the main theory that is followed. And it is that we have to, we as dissidents, must challenge, and I think we do that. But I have determined after years of doing that in order to make a real breakthrough, we have to come up with an alternative. That's just how the world has operated. That's just how mainstream science has operated. They will not basically give you any hearing unless you can show something that is better than the one they have. They're not satisfied that you are just going to show them what is wrong with what they are doing, unless it's something very dramatic. And I don't know what that could be. Maybe Jim's low orbit Michelson-Gale experiment or something like that. Although I believe they will find a way to discredit that if it really did work. So it is necessary to come up with a new theory to replace special relativity, which as dissidents, generally we believe to be wrong. I am satisfied that it is wrong for many reasons that I've espoused, just one of which is simply the existence of the ECI frame, which violates the relativity principle. And is, I consider that the elephant in the room, Jim, the existence of that frame, which is contrary to the principles of special relativity, but which nobody talks about. They try to embrace them both. I think some even go as to try to accommodate it, to use Roger A's terms, maybe shifting the goalposts to accommodate it. So this is where I believe pursuing the Lorentz Ether Theory is unlikely to be fruitful. I don't believe pursuing Galilean transformations at high speeds is likely to be fruitful. The Galilean transformations are important at low speeds. The celery transformations, and when you consider how they were arrived at, he used two experimental facts, codified them, and now that codified idea in the form of the celery transformations are making these predictions, which I said I have found to all be validated by experiment. So I am in the position now where I am advancing. I continue to advance, and I'm only doing that now, Ian, since I have this short time at the end, to advance the celery transformations as the correct transformations. And I am continuing to do work and taking some various steps, which I hope to, in the not too distant future, announce some of the steps that I have taken to move this program forward. But I am convinced, not because Celery and I were friends, but because of careful and exhaustive testing of his theory, I am convinced that his theory is the correct set of transformations. Good. I never met Professor Celery, regrettably. We only communicated by email. I understand that he attended one or two of these conferences that of the association, but he died before I was ever able to meet him. But we communicated. I am really very excited about moving that program forward because I believe I'm on the right track, and I will have more to say in the not too distant future. So thank you very much, Ian. And thank you for everyone for attending and listening in. Thank you.
Well, our thanks are due to you, Stephan, because you've given a lecture that I think everybody will agree has been most stimulating. I've been very happy to have you as a speaker on a number of occasions because you are a person who doesn't make statements without substantiating them. I mean, not everybody might accept your argumentation, but you actually go through in a logical, a sort of a Grecian logical way, and you quantify, you show some equations, and you say these are the values that you get under such and such circumstances. These are the values you get in experiment. Too many of us, and I could be a bit of a talker as well. We just make words and words and words. And I think it was Lord Kelvin who said that when you just describe something, you have a meager amount of information on it. But when you quantify it, your information increases quite dramatically. So it's very important to put numbers on these things and to put some equations in. Stephan has always done that. And with regard to the transformations and so on, I mean, I'm delighted that Stephan, in his summary, included the Celery transformations, because I didn't want to silence consideration of those today by any means at all. I mean, we're all open to consideration. And it's just that a couple of the previous presentations, which we were privileged enough to have Stephan make to us, did deal in some detail concerning the thinking that he had, indicating that the Celery transformations were actually the right transformations of the universe. And he gave very good reasons for that. Not all of us might agree with the details, but he gave very good reasons for that. So today, it was specifically dealing with his analytic ability to, dig down into the situation and see whether a modified version of the Lorentz transformations, namely the LET, would be satisfactory. And he's shown to his satisfaction, and I think he's given it logically. You might disagree with some of the details, but he's given it logically why the answer is no. The LET isn't really any better than the SRT in that regard. Now, if you go into, I'm delighted also, if I may say so, to my personal bias, I'm delighted also that we've kept AI out of the question. I mean, if you go into AI and start putting questions to it and bouncing the thing back, it'll probably say, oh yes, the LET is another form that you could use, and it'll give the right results and so on. We've kept that out of it. That is just a consolidation of what's on the web and what's in the public domain. And by the way, for my own part, I have exactly the same experience as Stephan with regard to these textbooks on special relativity. I have never seen the MG type experiments mentioned in them. I didn't know about that until long after I left college, actually. So these things are not. If you go into the Wikipedia, I think you can probably find something there, but what it will do is say, well, this is actually in accordance with SRT, and Stephan mentioned actually that Michelson and Gale themselves in their paper of 1925, the experiments 1925 papers a bit later, said at the end, yeah, this is consonant with an ether theory, but it's also consonant with a relativistic theory. So he's given us a lot to think about, and I'm very grateful to Stephan for the patience with which he deals with all the questions and with which he explains his propositions, because too many of us you just use words. Words are easy, and we can just waffle on a bit without describing exactly why we think a particular matter is important. So in a very short period of time, namely just under an hour, and now 2 hours with our discussions, we've had the benefit of Stephan's incisive analysis with regard to the LET, which have been grasped by some of us dissidents as an alternative to SRT. And I freely admit that I don't agree with every single aspect, but I think he's given us a lot of material to consider, and it's very hard to disagree with many of the points that he engages in during his deductive reasoning. So thank you so much on behalf of the CNPS for coming again and being such a good speaker. It's just come to the 2 hour mark, and I'm going to close the meeting. Regrettably, I'd like to consider it a bit more, but we will have an opportunity of discussing this further. And if there are any specific points that you want to raise with Stephan, you can always do that through us if you can't get in touch with him directly. I'm sure he'll be happy to engage in that. The private chat is still coming in. Stephan just put his private chat. Thank you, everyone. Thank you, everyone. Well, thank you, Stephan. So I'm going to close the recording now, end the stream. And thank you all very much. The people in Facebook, the people in YouTube, and the people in the green room. I asked every person in the green room today to speak, and he actually made very valuable comments. And most of all, thank you so much, Stephan. You're a jolly good fellow for fielding all our questions and giving a very coherent talk in a very logical way and in a very clear way. Thank you. Good day to everybody.